ANOVA before we start. I'm sure you have encountered this name severally in your analysis and even in your class, in your classwork. So we are going to cover one-way analysis of variance and the two-way From there, you can do multiple. So the maneuver, where we define more than one variable. We compare with more than one variable. We compare with other variables. Okay, but now you have to understand what we mean by analysis of variance, or the ANOVA. Then from there, we formulate the hypothesis, that is the null hypothesis and the alternative hypothesis. Kutoka hapo we go on. The first one is one way, and one-way analysis of variance, or the ANOVA. These are statistical technique that is used to compare mean of two. It is used to compare. Okay, there's an error here. Not two or more. It is two groups. See there, we are comparing this group and this other group, so that is one way. But what happens when we compare one group with multiple groups? That is two-way or multiple. So we compare means of two or more groups to determine if there is significant difference among them, right? And ANOVA is designed to analyze the variability between these groups and within groups to determine if indeed there is differences observed, if they are likely to be due to random chance, or if there is a genuine effect. One-way ANOVA, or one-way analysis of variance, will assume that data follows a normal distribution and that the variance among the groups being compared are approximately equal, right? These variances of the two groups, we assume that they are approximately equal, or they are closely equal. So that is the assumptions that we have, that one need to consider when doing analysis of variance. So the analysis involves calculating the F statistics, and remember, from F we get, from F is now when we get the P value that we use to either reject or fail to reject the null hypothesis. So this F statistic is the ratio of between group variability to the within group variability, right? So if F statistic is large enough to reject the null hypothesis, which assume no significant differences between groups, it is suggested that at least one of the group means is significantly different from the others. So in this presentation, we will look at how we can perform one-way analysis of variance, that is ANOVA, for independent groups using SPSS, and how to interpret the result using data case HSD, data case HSD. We have an example, and we will demonstrate one-way analysis of variance using the dataset that was shared with you. It is inside the zipped file, right? So are you able to locate the data? Joy?
For now sahi niko na shida ya laptop.
Uh-huh.
Na follow using the phone.
Okay, no problem. Let's continue.
Yeah.
Hey, friend, welcome back. Karibu sana, karibu. Better to be late than never. So, this data of ours contains a number of different variables. When you open the data set, you will see that we have this kind of variables. We have education, frisbee distance, water, sun, height. Then this is the data. This is the data. We have 40 cases. We have 40 cases. Now, for the purpose of this tutorial, we will be interested to know whether level of education has an effect on ability of a person to throw a frisbee. I think you understand what we mean by frisbee. Frisbee is a game. Inakaa kama ya kasari. You throw from one place to another. Are you familiar with the frisbee game, Frida? Aki nisiongea mkuwa mnanyamaza. Frida, are you
Yes.
have you do you know how to play frisbee? Frisbee.
No.
But you know that game.
No.
You know that game?
I think I've seen it somewhere.
Okay. Frisbee ni mchezo ya sahani. You throw inakuwa like something like a sahani. You throw from one place to another. Now, what you want to do or to know from this example of ours, we want to know whether the level of education, whether you are from 4 level, whether you are graduated, whether you are still in high school graduate, whether those levels of education has effect on someone's ability now to throw that frisbee. Do you understand the concept that you want to test here? Nataka mniambie yes or no. You understand the concept now, right? Now, we will be analyzing the distances of frisbee per group, per education group, right? So, our independent, when you open up this data set, you will note that we have education here and frisbee. Okay, let's click this and see. So, we have graduate, postgraduate, and high school. Postgraduate, high school, graduate. So, basically, we have 3 levels of education here, and we have the frisbee distance. So, these are graduates. Amedrew frisbee ikaenda 56 meters. Postgraduate amerusha ikaenda 34. Now, we want to do to compare education and this frisbee distance and tell whether the level of education has ability on throwing this ball. So that is the concept that we want to demonstrate here. Our independent variable therefore is the education, which has 3 levels, that is high school, graduate, and postgraduate. And our dependent variable is frisbee throwing distance, right? That is the distance a subject throws a frisbee. So while your data is in this format, or while your data is stored in SPSS like this, you carry out one-way analysis of variance by clicking on analyze, compare means, and you click on one-way ANOVA. So if you have any question as we proceed, please feel free to ask. This is the last week, so utilize the remaining time wisely. Gain more, so because you may not gain again from bounty hivi karibuni, sawa. Yeah, so time is money, make use of it. So click on one way, right? Click on one way. From there you bring education, here. You move education to the factor box, and frisbee distance on the dependent list, so we bring education here, and frisbee distance we move it to that other box. This thing is misbehaving. Let me do something. Oh, I'm making it worse. Okay, I think it's okay. Ikiwa hapo. So we drag education to the factor box and frisbee on the dependent list, the way I've done here. Okay, let me cancel this one. No. The way I've done here. Then what else? Remember, we are going to use Turkey. We are going to use the Turkey's method. From there, to set up this test now, you will go to get your independent variable into the factor box, the way we have done, and the dependent variable into the dependent list box. You can do this by dragging blah blah blah. Yes, so after you have moved the variables over, you should click the post hoc button, which will allow you to specify the post hoc test, right? The post hoc test you wish to run, and the ANOVA test will tell you whether there is significant difference between mean of 2 or more levels of variables, right? Remember, for our case we have only one. We have 2 variables, and that is education level, and the frisbee distance. So however, if you have got more than two levels, it is not going to tell you between which of the various pairs of means the difference is significant. So you'll need to do post hoc test to find these out. So for our case, we will not be able to do so, because our levels are 3. We have 3 levels of education. So you click on post hoc, this one here, click on post hoc, and equal variance assumed of Turkey. Let's see, Turkey. Then you can vary this if you want the significance level, but I prefer we continue with it the way. Click continue, and you will be able now to produce the output by clicking on OK button. Let's see. No. Before we click on OK button, now press continue to return to the previous box, and okay, click on options. Click on options so that you can get the descriptive statistics for your variables. Another thing we can get is statistics on homogeneity of variance and mean plot So click on options, mark the descriptive statistics box, homogeneity of variance tests, and mean plot. Click on mean plot, then click continue. Click continue, and from there you can click OK. After clicking OK, we have this kind of output. Now I want you to be very keen on how we interpret this kind of output. So Brian, welcome back. We have missed your absence, so feel free to ask questions where you don't understand. So let's continue. So after clicking continue and click OK, you will get the result. So at the very least, you should select the homogeneity of variance test option, since the homogeneity of variance is required for the ANOVA test, right? Descriptive statistics and mean plot are also useful. Once you made the selections, click continue and click OK to get this kind of output. So get this kind of output. SPSS will produce a lot of data for one-way ANOVA test. So let's deal with the important bits in turn. You will notice that SPSS will give you descriptive statistics, the test of homogeneity of variances, ANOVA, that is analysis of variance, post hoc test, and homogeneous subject together with the mean plot that we have just mapped. Now, how do we interpret the output? How do we interpret the output? Number one, let's interpret the descriptives. This table. Where is it? This one. So this table. The interpretation is very direct for the descriptive statistics. We have n. N is the number of sample per these entries. For example, in our data we have 13 graduates, we have 17 postgraduates, we have 10 high school, and the total sample is 40, right? From graduates, those who participated in the survey, they had a mean of 45.4 seats. So postgraduate, they had a mean of 53.94, right? We have the high school mean score of 46.40. So from these three groups, we can tell that postgraduates they have highest mean score of the distances that each of the participants recorded, right? We have standard deviations. We have standard deviations for the graduate, postgraduate, and the high school. Another thing is the standard error. Standard errors, we have the standard errors tuko nazo hapa, and 95% confidence interval for mean. You understand what we mean by confidence interval? The mean for graduate ranges between confidence, the lower bound is 36.66 and the upper bound is 54.27. We have the minimum value, the minimum value from the graduate records. This is the same as from graduates. We have one person who recorded 23, and the maximum record or maximum distance from that particular group recorded was 68. So these are simple descriptive statistics for the descriptive. So let's see. So test for homogeneity of variance. Let's check this one now. I think these are straightforward, right? Nani hajaelewa mpaka hapo? How do we interpret descriptive statistics? Iko hivyo tu vyenye unaiona, just that simple. Test of homogeneity of variance. We have the Levin statistics of 0.293 degree of freedom 1, df1, df2, and the significance value. Now, how do we interpret these values on test of homogeneity of variance? That table presents the result of test of homogeneity of variance for the variable Frisbee distance among three groups. So the test is conducted to determine if the variability of the Frisbee distance variable is similar or different across all the group, right? Across or similar across all the group. And here is the interpretation of that statistic. The Levin statistic of 0.293, this one here, Levin 0.293, interpretation of that Levin statistic. This statistic is for Levin's test of homogeneity of variance. So in this case, the Levin statistic is 0.293. The df1 and df2, they represent the degrees of freedoms associated with the Levin statistics. Remember, we don't have df3 because we had 3 groups, so we less 1. So we less 1. df1 is the numerator degree of freedom, and df2 is the denominator degree of the freedom. So those are the values. The significance value, this column will represent the p-value that is now associated with the test statistic, right? So the p-value indicates the probability of obtaining the observed result for more extreme if the null hypothesis is true. If the null hypothesis is true. So in this case, the p-value is 0.748. Question for you. What is the null hypothesis for the Levine test? What is that hypothesis? The hypothesis in gani? Hypothesis for the Levine. Hypothesis for the Levine. I want one of you to try. One of you to try. One of you to try. You can try. Ama itakuwa kwa nini as theory. So this week I want you to do some theories just to test how you understand things without doing them. So how you understand things even before doing them. So let's continue. Brian,
Yes.
do you have the note?
Yeah, niko nayo, but I was wondering ni data gani mnatumia?
Iko hapo kwa hiyo note.
Okay.
Kwa the zipped file kuko na Word document na SPSS data file. A file in SPSS format. Unaiona hiyo file? Nataka kusikia kutoka kwako.
Sijaona.
Huh?
Uoni?
I mean this one, I shared this, ukifungua this zipped folder, kuna hii SPSS lesson then untitled 1.sav.
Oh yeah, niliona.
So ukiopen this one, ndi itakuja na hiyo data, sawa.
Okay.
Aki, imagine, imagine inaweza kuwa this is the last time ya kusoma this ANOVA. So the next time to talk of ANOVA, you will be doing for someone else or for yourself. So you better follow what you are doing. So there. Yeah, na itawahi change. ANOVA ni ANOVA. So ni hii tu yenye tunafanya. One way ni one way. Hata ukienda kwa stata ni the same. So jua kuitumia sasa kwa SPSS. Sasa. Okay. Let's continue. Let's now interpret this test of homogeneity of variance. The p-value is 0.748. This one here. The significance value, right? And how do we interpret it? So the test of homogeneity of variance assesses whether the variability of Frisbee distance variable differs significantly across the groups, right? So in this case, the p-value is 0.748, which is greater than the significance level of 0.05. So there is no significant evidence to suggest that the variability of frisbee distance differs among these groups. So no. Or what do we do when the p-value is greater than the significance level? What do we do? Tunafanyanga aje in statistics? Yes? Friend, what do we do when the p-value is greater than significant value of 0.05? Wanga tunafanya aje?
We reject.
We reject
I'm
them.
not sure.
We reject.
Hiyo inanichanganya.
Yeah, p-values.
Yes.
Joy, what do we do when p-value is greater than the threshold of 0.05? Do we reject or fail to reject?
Not
Not
sure.
sure. Okay. From today, henceforth, if p-value mnanipata kweli? If p-value is less than alpha or less than 0.05, we reject. We reject the null hypothesis. If the p-value is greater, what do we do? So for our case here, I want you to check the hypothesis that we are dealing with here. So the test of homogeneity of variance assesses whether we have variability of frisbee distance variable if this variability differs significantly across the groups. Yes? So we have got the p-value of 0.748, which is greater than the conventional 0.05. So there is no evidence. There is no evidence to suggest that this frisbee differs among these groups. So, yeah. So it's that simple.
Kindly repeat about the p-value.
About the
My
p-value.
network is unstable, so I didn't hear.
Okay. I will talk of p-value and test statistics. So, p-value and test statistics. I want as we reflect back in the campus. Hatukuwa tunatumia p-value. P-value is generated by computers, right? What were we using?
Was it t-test? Something like that.
Okay, we were using test statistics. Sina yenye ulikuwa una calculate alafu you refer to tulikuwa tunafanya reference wapi? Hey, watu nataka muniambie.
Can't even remember.
Okay, nikusahau, mumesahau. Mumewahi tumia statistical table? Nani amewahi tumia statistical table? Brianna, okay. Frinda, umewahi tumia statistical table campus?
Yes.
Yes. Joy, umewahi tumia?
Bado ziko hapo.
Hujawahi tumia statistical table? Uh, mumewahi fanya unit inaitwa test of hypothesis?
Bado.
Okay, I think Joy ndiye hana idea, but Brianna, you have the idea. Frinda, are you familiar with the statistical table?
I'm not sure I am. It
Uh-huh.
was a long time ago, but I think I remember something to do with test of hypothesis.
Yes, something to do with the t-test, sindio?
Yes. Yes.
The Z iso
Yeah.
test. Yeah. So,
Yes.
pale campus, we were not using the p-values. Sababu, most of the time in calculations, you cannot calculate the p-value, but using the concepts or theories from tables, you can calculate the test statistic. Or, yes, test statistic inamaanisha hiyo test kwa t-test kuna that test statistic yenye unakuwa nayo kwa f, kuna hiyo f value, right? So tulikuwa tuna compare hizo vitu na the critical value sasa yenye imecalculate ikawekwa kwa the statistical table, sawa sawa. But now in computer hapa hatuna hiyo time ya kuangalia kwa kitabu, tunatumia sasa the p value. P value yenye inatolewa sasa na computer ndio most of data analyst wanatumia either to reject or fail to reject the null hypothesis. Another thing, each test iko na its hypothesis, right? The null and alternative hypothesis, they are different, sindio? They are different. Kuna zenye zina measure the associations, hizo blah blah blah, all those things, right? Now, theory yenye hautawahi sahau from today henceforth, from today henceforth, if the p value, get the point clear, if the p value is closer to 0, right? If the p value equal closer to 0, we have very strong evidence against the null hypothesis, right? We have stronger, very strong evidence. But now, remember in statistics, we do estimations, right? So everything we do is just a matter of estimation. Now, your evidence, that is strong evidence now, we give it a range from 0 to 0.05. So from 0 to 0.05, so 0 ni very very strong, inaenda kikuwa wiki kidogo 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 mpaka kwa tunaipea margin sasa, a margin of 0.05. So ukipata p value in a range between 0 and 0.05, or that p value is less than 0.05, we have enough evidence to reject the null hypothesis. So if the p value is greater than, if the p value is greater than 0.05, we don't have the evidence to reject the null hypothesis. So we fail to reject the null hypothesis if our p value is greater than 0.05. Mumeelewa hiyo concept? Brianna, Frinda, and Joy.
Nimeelewa.
Yes.
Very good. Joy?
Nimeshika.
Okay, let's continue now. Let's continue now. So therefore, based on this test of homogeneity of variance, we can assume that the assumption of homogeneity of variance is met, indicating that the variability of frisbee distance is reasonably consistent across the groups being compared. So, yeah, just that simple. Let's interpret the ANOVA table. Where is it? We have it here. Multiple comparison. This one here. So this one here. We wanted to do analysis of variance between groups, between these three groups, and remember we are interested with the p-value. We are interested with the p-value. So campus hatukuwa tunafika hapa, tulikuwa tunafanya nini, tunafika hapa kwa test statistic, that is the f, then we compare with the t, with the value from the statistical table, then we do conclusions. Okay, this is the p-value of 0.245. P-value of 0.245. This p-value is greater than 0.05, right? Is greater than 0.05. How do we interpret it? This is the F statistic. The significance, this column will represent the p-value that is associated with the F statistics. So it indicates the probability of obtaining the observed result, or more extreme if the null hypothesis is true. If the null hypothesis is true. So in this case, the p-value is 0.245, which is greater than the conventional significance level of 0.05. Therefore, okay, do we reject or fail to reject the null hypothesis? Because this 0.245 is greater than 0.05. Do we reject or fail to reject the null hypothesis? We fail to reject, right? So we fail to reject the null hypothesis. Therefore, there is no significant evidence. We don't have that evidence to suggest that the mean of frisbee differs among the groups. So therefore, based on the ANOVA, there is no significant difference in the mean of frisbee distance between these groups. Another one is the post hoc test. Post hoc test. This test here. This one here. Let's see the documentation that we have here. So this table presents the result of multiple now comparison using the Takei's honestly significant difference, the HSD, honestly significant difference, for the value of frisbee distance across different levels of education, across graduate group, postgraduate group and the high school group. So the test is conducted to compare the mean differences between each pair of education level and determine if they are statistically significant. So here is the interpretation of this statistic. The table is divided into 3 sections, as you can see, 1, 2, 3. That is between between graduates, postgraduates, and comparison between graduates and postgraduates, comparison between graduates and high school, and the comparison between postgraduate and high school. So each section provides the following information. We have the mean, standard error, significance, that's the p-values. Remember, we will concentrate more on the p-values to tell if the comparison is indeed statistical. Education and education, this one here, this value, this column and this column ndio tunaanzia nayo. So if you have any question, you can ask as we progress. The column indicates 2 education levels being compared, right? Number 2, mean difference, the IJ. This column represents the difference in mean of frisbee distance between 2 education levels being compared. For example, in the comparison between graduate and postgraduate, the mean difference is negative 8.48, indicating that the mean distance for the graduate group is lower than the postgraduate group. And actually you can tell from this one here, you can tell from these means, right? The mean of postgraduate and graduate. What is the difference between these two? Between 53.94 and 45.46. I'm sure you will get this answer. Negative 8 point blah blah blah. So we have the standard error. This column will represent the standard errors that are associated with mean difference, and it quantifies the precision of the estimated mean difference, right? We have this significance figures. This column will basically represent the p-values that are associated with the mean difference. So it indicates the probability of obtaining the observed mean difference, or more extreme if the null hypothesis is true. So a p-value below the chosen significance level of 0.05 suggests statistically significant difference. So this definition is straightforward, yeah. So you can use this knowledge to interpret those other values. Now, for example, let's consider comparison between graduates and postgraduates, right? Between graduates and postgraduates. So okay, I want one of you to tell me whether this comparison is statistically significant here. The significance value is 0.279. 0. Munanipata kweli? Are we together? Brianna, nimepotelea wapi?
Yes,
Nimepotelea wapi?
ulitoka.
Network yangu ndi imesumbua nikatoka bila kujua. Okay. So tulikuwa tumeachia wapi, kwa which interpretation? Yeah? Tulikuwa tumeachia kwa which interpretation?
Hapo kwa postgraduate sijui nini hizo kitu.
Okay, this is, I think it's this interpretation here. Let me see. The post-hoc test, right?
Yaani hapo.
So sijapotea for long. Dakika kidogo tu. Okay. Post-hoc test. Post-hoc test. So this test is basically used to compare this. Okay, let's begin interpretation for the whole table, right? So hapo kuna nikianzia katikati kuna wenye atapotea. So this table basically represents the result of multiple comparison using the Takes Honesty Significance Difference, the HSD test for the variable frisbee distance across different levels of education. And the test is conducted to compare the mean difference between each pair of education level and determine if they are statistically significant. So here's how we interpret. This table is divided into three levels of education that we have. We have comparison of graduate and postgraduate, comparison between graduate and high school, right? The comparison between postgraduate and the high school, postgraduate and the high school. So each section will basically provide these values. Okay, we have this education here and education here. I want us to concentrate with the significance values together with the mean difference, together with the mean difference. And I said the mean difference, this column represents the difference in the mean, that is frisbee distance between the two education levels being compared. For example, in the comparison between graduate and postgraduate, the mean difference is negative 8.48, indicating that the mean distance for the graduate group is lower than the postgraduate group. So you have the standard error, blah blah blah, all those things. Now we have the significance value. I want you to be very keen here. How do we interpret the significance values? This column represents the p values that are associated with the mean difference, and it indicates the probability of obtaining the observed mean difference for more or more extreme if the null hypothesis is true. And a p value below the chosen significance level, that is 0.05, suggests that this is statistically significant difference. It suggests that is we have a statistically significant difference. Mr. Enoch Mainye, welcome to this group. even though you are late, feel much welcomed, right? Feel much welcome. Stay with us till we end the lesson, and welcome even tomorrow. Yeah. So kesho we always start our classes at exactly 7 to 8 that, so we have like 20 minutes to go. So Mr. Enoch, you can say hi to
Thank you.
us. Okay,
Thank you.
welcome back. So that's how we interpret this value. If the p value is below the significance level of 0.05, it suggests that that difference is statistically significant. But if you check our tables, here, I think all the significance values are greater than 0.05. So it means the comparison or the differences between those three levels of education, they are not statistically significant. So there's no difference between them. That's what we mean by that point.
What's about the standard error?
Standard error is basically the error of estimates. Okay, by the way, standard error ni nini? What do you understand by the name standard error? Inakuanga imetoka wapi? Nataka tuongee kama data analyst. Yes? Nataka kusikia kutoka kwenu. What is standard error of the estimates? Okay. Standard error, these errors that you can see here, these are errors of the mean. These are errors of the mean. They indicate, these standard errors, they indicate how different the population mean is likely to be from a sample mean. Are we together? Is that definition enough, or we add something else? Standard error will indicate how different the population mean is likely to differ or to be away from the sample mean. So remember, we are dealing with the sample, right? We are dealing with the sample. So for example, from this sample of graduates, and we have standard error of 5.463. This is the probably error, either plus or minus, of the total population of the graduates group, if they were to participate in this study, all of them. Sawa.
Sawa.
Yeah.
Sasa tuna interpret aje kwa hii analysis?
Hiyo haina shinda, we don't interpret the standard error.
Okay.
Yeah, so our main intention was to interpret what? To interpret P values and tell whether those differences are statistically significant or not. So that is it. ache tuende kwa the other. So Frisbee, you will go through this at your own time. The slide number 13. Let's go on two-way ANOVA in SPSS. So. And this is the example that we want to use to demonstrate this one. Hapa tutakuwa haraka kidogo because the time is not on our side. So, a botanist wants to know whether or not plant growth is influenced by sunlight exposure and watering frequency. So, hiyo ni swali hata unaweza jiuliza. I want to know whether this plant growth is influenced by sunlight exposure and watering frequency. So, this person plants 40 seeds. So, this was a typing error. So, she plants 40 seeds and lets them grow for 2 months under different conditions for sunlight exposure and watering frequency. So, after 2 months, she records the height of each plant. So, and this recording is in inches, right? Use the following steps to perform a two-way ANOVA to determine if watering frequency and sunlight exposure have a significant effect on plant growth, and determine if there is any interaction that affects between watering frequency and sunlight exposure. So we are going to use these other columns. We have water, sun, and height, right? So you can click this, and who can tell me, click this icon here, I get a values here instead of strings. Who can tell me the reason why? Who can tell the reason? Okay, Frinda. Frinda, I'm referring to you because you asked a question about this thing. Now.
Okay.
Do you have any research? Do you have a way out for that before I respond?
Oh, so I think those numbers are used to denote some values.
Yes.
Yeah, they used to define some values. So once you click the icon, it goes back to where you had defined the values and brings out the real value.
Oh yes, that is it. Now, kwa question yenye ulikuwa umeuliza, this is what happens. If your data is in this format, so and you want to convert these to numbers, one thing, you have to convert values first. You have to convert these strings first, so before ukuje to change on the variable view. So you have to change on the data view first, from this format, from the strings to numbers. For example, you want 1 to represent low, 2 to represent medium. Now, how do you do that? You just click on this column and click Control F, see there. Then click on replace. Then I want to find low, see there, and replace, for example, with 1. So then replace all. So that is what we do. From there, you repeat the same for medium mpaka hapa kukuwe na numbers alone. From there now you can click on data view, on the variable view, and change the data type without missing or without losing these strings. So, Frinda, is your question answered?
One more question.
Uh-huh.
So if you change those values, will they reflect in the variable view?
Okay, if you change these variables to numbers, hapa tu kutakuwa na strings. For example, kama hii ilikuwa string, it will remain to be string. Sawa. Or I can demonstrate with one here, sindio? Are we together?
Okay, yes.
For example, suppose we have gender. Sawa. Gender ikue string. Sawa. Gender ikue string. Then
Yes.
from there we have male, sindio? Female, male, male. Sawa. Suppose we have those values. Na ninataka kuzichange from string to numbers. Sawa. Nikikuja hapa, when I click change to numbers, I will lose those data. Check. Numeric, let's see. Si unaona hakuna hiyo data, si ndio?
Yes.
Imepotea. Sawa. Na nikibring back my string, what happens? Si unaona zimepotea, si ndio? Hizo
Yes.
values zilipotea. So the best thing to do here, kama ilikuwa kwa string na nataka kuzichange zikuwe in variable, na hapa ilikuwa male, let's see, male, female, sawa. Suppose sasa nataka kuchange hizo zikuwe in hiyo format inataka. So you click there, control F, find and replace, find male, replace with 1. Sawa. So replace all. Sawa.
Yes.
Nikireplace all nasema okay. Then from there, hapa imesema FE1 because kulikuwa na male hapa, kitu ka male hapa, si ndio? So I
Yes.
control F, find FE1, si ndio?
Yes.
Replace with the 2. So replace all. Sawa. So unaona my values zimekuwa replaced. So ninaenda hapa sasa kwa my gender. Hapa ninaenda ninazidefine hapa. Number 1 ilikuwa male, si ndio?
Yes.
Then I click and number 2 ilikuwa female, si ndio?
Yes.
I click
Yes.
and click OK. Nikikuja, then from there I can change now the data type to numeric and I click OK. So OK. From there click on data. Si unaona zimekuja hapa, you can click hapa na unazipata. Sawa.
Okay. So what if
Uh-huh.
I decide to define in the variable view,
Uh-huh.
like I before I change to numeric,
Uh-huh.
I go and in the values
Mm-hmm.
I define them, 1 represent male
Mm-hmm.
and then 2 represent female. So if I convert, will the data disappear?
You will miss the data here. So
Okay.
you have to change on the data view first, then you define on the variable view. So
Yes, thank you.
yeah, that is it. So the other one was on ANOVA, the two-way ANOVA, two-way analysis of variance. Inaenda mpaka wapi? Si mengi, si ndio? So two-way. Now, On two-way, you click on general linear model. You click on general, click on analyze general linear model, then click on univariate. So you bring your height on the dependent variable and fixed factors unazileta kwa hapa, which is water and sun. And even if we had to compare height with more than two variables, si tungezileta tu zote hapa kwa the fixed fixed factor. So tungezileta hapa tu kwa fixed factor, but now we wanted to add something else. So you click on, so we have dragged those here, click on plot button, click on the plot button. Let's see, click on the plot button. You bring sun on separated line. So let's see. Yes, bring sun on separated line and water on the horizontal line. Then from there you click on this hand. So click on that hand. Yeah, then you click on continue. Click on continue. From there, what do we do again? The next thing, you click on post hoc button, and you can define the take, right? We can click on the take. So let's continue. So click on post hoc and check, make sure that the take is checked. So take is checked, then click on continue, click continue, and from there you just click OK and get your output. Let's see. Yes, this is the output now for more than one for more than one what? More than one variable. That is the univariate now analysis of variance. We have between subjective factors. We have daily, weekly, low, medium, high, yeah, and the values that they are representing that estimation. We have test of between subject effects. We have it here. We have the post hoc and profile plots, and I think we can now interpret this output here. So this table represents the result of test of between subject effect. I think the interpretations that here are very simple. You can go through them at your own time. So even if you have I think now up to now you can do one-way analysis of variance and a multiple, right? And multiple or two-way, or the two-way analysis of variance. So or two-way analysis of variance, and two ways multiple. So if even you have three, you just bring them to the factor box. Do you have anything to say, or we can just call it a lesson up to that point? So go through the slides at your own time so that you can be more familiar with them. So